Hi everyone, I'm Nimita. My partner is Kenny. So today we are talking about super resolution or Thailand landmark using the laminate. These landmarks are very special to Thailand culture, history, and tourism. So we choose them because they are well known and improving their photo make them a bit different. The first one is we are talking about landmark or Thailand. So this slide explains the main place we choose for our projects. Our project use image super resolution. There's a computer vision method that take a blurred or low quality photo and make it clear and detailed. So we wanted to test this on Thailand most famous landmark. We picked four key city: Bangkok, Chiang Mai, Pattaya, and Phuket. Next slide, please. So Bangkok. Bangkok is the Thailand busy capital and full of amazing sights. So the Green Palace, this was a lower home for King of the Siam until the 1092 1920 century. So today, this day used for lower ceremony and big event. So what are they? So also know that the Empire of Dawn is famous for its beautiful design and manure. It even hold the King Rama II under its main Buddha image. So Mahalakun Tower. So it's a modest sky quiver with a unique visual design. So it shows the Bangkok fast growth and new style of architecture. So these three elements show both Bangkok history and modern future. So next slide, please. So let's talk about Chiang Mai. So now let's go the north to Chiang Mai, a city with a lot of culture and nature. Element natural park. This is the safe home for elephant or resort for logging, service or head tourism walk. Uh, Elephant can walk freely. It also teaches visitor and about kind of the sustainable tourism. So the next one is the Gate. So this old gate was one part of the city wall built to protect Chiang Mai during the London Kingdom. So today is the famous place for festival and lawyer event. So it's where history and community life meet. So next slide, please. Pattaya. Pattaya is began as a quiet fishing village until the 1960th century. So one is transformed into the major seaside resort during the Vietnam War era, and today is the Australia City blending cultural landmark. So living beaches and nightlife with the island escape. So next slide, please. Phuket. Finally, we left head south of Phuket. Phuket was once a major trading port for tin and rubber, influenced by Portuguese, Chinese, and Malay culture. So now it's the Thailand largest island and one of the world top beach destination. So it's famous for clear blue water, soft sandy beaches, and vibrant culture. Or places like the Phi Island or Kata Beach show Phuket tropical beauty and manipulated best. The next one will be presented by Kan Yitu.
Uh, so we're gonna be enhancing these landmarks with super resolution. Why super resolution? Sometimes images capture in poor lighting or in low resolution or in compressed formats. This can lead to blurry images and losing details, which is a problem when showcasing landmarks online or in digital archives. Super resolution helps recover details beyond simple upscaling. Below is an example picture of super resolution. So in this project, we're going to be exploring three different techniques for super resolution. They are number one, CNN-based models. These enhance images by detecting local patterns like edges and texture with convolution filters. The second one is GAN-based models. These generate photorealistic images using a generator discriminator computation. The final one is transformer-based model. These capture global context with self-attention to produce high quality and balanced result. Below are the list of models we used. They include EDSR, ESPCN, FSR, CNN, LEBSRN, ESRGN, and finally BSRGN plus SwinIR for a fusion model. So dataset. First, we collect a collection of datasets to prepare. Here we have the few example images from our dataset. These include Waterong, Bangkok, Pattaya City, Phuket, Chiang Mai, Bridge on the River Kwai, and Mahanakorn Tower. So the pipeline we use for this project include, first of all, we start out with a low resolution image from our dataset. Then we pre-process by normalizing, resizing, or specifying images as required by the specific model. And the third one, we feed the LR image into a train as our model. as CNN, GNN, or transformer based on the model. Then we upscale the model, the model reconstruct missing details and output a high resolution image. Then we go into post-processing. And here we apply enhancement such as denoising, sharpening, or color correction if needed. Finally, we output the final high-resolution image with improved clarity and detail. Below are the example code snippets from our project. So these are the results from CNN-based model. And these models rely on convolution filters to detect edges, texture, and local patterns in images. They are most widely used and efficient for structural tasks. And here the result from the GN-based models. Generated adversarial networks create more photorealistic details by training a generator and discriminator in competition. The downside of GN-based model is it is slower compared to CNN models. Finally, we have transformer models. Transformers use self-attention to capture global context in the image. This allows them to balance detail, sharpness, and consistency across the image. The downside of this model is it is very slow and resource heavy on the computer you're using. Analysis of each model. Starting with FSS CNN, this was the first model we tested. However, it sacrifices sharpness and realism, so it's best suited for real-time application where speed matters most. The next one is ESBCN. This is a fast and lightweight model. It is not as sharp, but it runs well on mobile devices, making it ideal for portable and embedded systems. EDSR. This model gave us a balanced performance. It produces sharper details than FSRCNN or ESBCN. While not the most realistic, it's excellent for benchmark text where accuracy is key. LabSRN, similar to EDSR, it uses a progressive approach to sharpen the image in steps. It's particularly useful for progressive upscaling tasks such as multi-stage restoration. Then we have ESRGNN. This one is slower, but it excels in producing realistic texture and photo-like images. It is ideal when you need the output to look natural, such as for tourism or media use. Finally, we have the BSRGN swing IR combination. This gives us the highest quality results overall. It handles noise and artifacts very well, producing sharp and realistic images. The downside is speed. It is the slowest model we've used. When quality is top priority, this is the best option. In conclusion, super resolution adds a landmark imagery far beyond simple resizing. GAN and transformer-based approaches deliver near photorealistic results, making them very promising for tourism, digital culture, and beyond. This is all for our presentation. Thank you for your attention.